Hello, Mr. Ryan, are you right?
Yeah.
So we given n unique integer, positive integer, or distinct integers. We are given n unique distinct integer, for example, like 3, 4, 199. And I want you to come up with an approach to return any number which is not the maximum or minimum of the array. For example, this is array A. So we're given, for example, given this array, right? The maximum is 100, the minimum is 3. I want you to come up with an algorithm that returns a number neither of these. So you can give me 4 or you can give me 99. Okay? N unique integer, positive integer. So if no such numbers, then we return -1. Okay, so one question. In what cases there is no such numbers?
When there's 2 or 1.
Yeah, when the number of elements, when the number of numbers in the array is just 1 or 2, then there's no such number because you can't find such number. Am I right? Okay? Okay, so that's good. Okay, so what's your approach? Any idea?
Sort it and then choose the second number.
Well done, sort it. So we can just sort, yeah, sort it and then return which number?
The second one.
But
Second number is A1, right?
if there's not
Yeah.
2.
Okay, yeah, obviously we need to check, right? If the length of A is smaller or equal than 2, then we return
-1.
-1, okay? That's good. What's the time complexity?
And login.
Yeah, because there are a number, sorting is always looking. Can we do better?
Yeah.
So finding the maximum minimum, right? So we can just find the maximum and minimum in O(n) time. Look,
And then we just take the
mean value equals the mean, the A. Max V equals the ratio
Thank you.
A, okay? So now we have these two. So we just have to go through the array to see. For I in A, if I not equal mean V, if it's not a minimum, and also if not equal the maximum, then we return I, right? Okay? And return -1. Actually we can reuse this bit of code, okay? Okay, the time complexity for these two is O(n), right? Finding the minimum. If I give you an array, you want to find the minimum or maximum, it's O(n) time, am I right? Okay, so look, how do we find the minimum and maximum? We go through this array, am I right? Yes? 3. Current minimum is 3. Current minimum is 3, okay? And if we have a value which is less than the current minimum, then we update the current minimum, okay? And the vice versa for the maximum. For these, right, we are calling this mean and max function. Each function takes O(n) time. We can actually go through this array once and find the minimum and maximum. Am I right? Yes? We don't need to perform this linear search twice. Okay, and then these, for these we can do this using the next function, right? Return next I for I in A if I not equal min V and I not equal max V. And then we can give a second parameter if we don't find such value -1. But actually because we are given these distinct numbers and we already check the length of the elements is less than 2, and here we have more than 2 numbers here. So we don't have this -1 situation, am I right? Yes?
yeah.
If I tell you there are 3 numbers, they are all different, unique, there must be an answer which is not a minimum and maximum, am I right?
Yeah.
Okay? This is O(n), okay? This is O(n), right? Can we do better?
Yes. We can make it O1.
Yes, O(n), how? Okay, so remember the sentence I was just saying. If there are 3 numbers, okay, listen carefully. If there are 3 numbers, here, right, at this point, if there are 3 numbers, here we have at least 3 numbers, okay. If there are 3 numbers and they are different, do we know the answer? Can we find a number which is not the maximum and minimum? If there are 3 numbers, okay.
Yeah.
Okay, so do we have to, if there are million numbers here, do we have to, go through the million numbers? For example, the sorting, we need to go through the million numbers. Here, we
You
need
only
to.
need to the. We only need to check.
Wait. For that one, if it's lower than 2 and you sorted, what if there's like for the first? What if all the numbers there are the same?
No, that's what I'm saying. This thing, okay, the given, okay. Here, a million number. We need to sort it. Obviously, we need to visit often. Finding the minimum or maximum. Obviously, we need to go through that. But as I said, there are three numbers. At least three numbers.
Check 3 numbers and then you find the
Second number.
yeah.
Okay, say yes. Checking 3 numbers. We just have to check the first 3 numbers. Okay. We don't care. There are million numbers here, right? Am I right? We just have to check the first 3 numbers. How do we check the first 3 numbers? Of what? Okay, I'll give you these 3 for 100.
Yeah, 4. 4, yeah.
Okay. Yes, it's 4, right? Because if there are a million here, we don't care, right? Yeah? Okay? Makes sense, yeah?
Yeah.
Okay. So how can we check the first 3 numbers? What are we doing actually for the first 3 numbers?
Checking.
Checking which?
Sorting.
Yeah, we're checking the first 3 number. We sort it. We can sort it, right? So we can just say another array, the first 3 number, right? So B equals A up to the first 3 numbers, yeah? This is the first 3 number, and we sort it. Sort it. And then we return, again, we return the middle one, right? Yeah? We return the middle one, which is A1. It's similar, so we actually just need to sort the first 3 numbers instead of sorting the entire array. And the time complexity for this one is, what's the time complexity of sorting 3 numbers?
O1.
Yes, exactly, O1.
At least you said it win.
Okay. Sorting 3 numbers, yeah. Another way is slightly different. Let's say the AB equals the first number, which is the A is the minimum, right? Mean A0, A1, or yeah, and then maximum A0, A1. Okay. So now A and B. A is the minimum of the first 2 numbers. B is the maximum of the first 2 numbers. And then I check the third number. If the third number, okay, listen carefully, look, A, B. A smaller than B, right? Okay. A is the smaller number of the first 2 number. B is the big number, the large number of the first 2 number. If the third number is between A and B, so what's the answer?
Then the third number.
Well done. And if the third number is smaller than A, what should we return?
A.
A. If otherwise, if it should be bigger than B, then what should we return?
B.
Well done. Exactly. It's the same thing. Then here, so sort it. Okay? Or 1, right?
Yeah.
Okay. So what have you learned? What's the biggest takeaway? What's
Just
the
take
biggest?
if when you're looking for the biggest takeaway is when you're looking for a number that's not the minimum or the maximum, just check 3.
Yeah, just check the first 3. Yeah. The approach, Eric, your first approach, this is straightforward, intuitive. You give a very quick, intuitive method, which is to sort.
Yeah.
Very good. Again. This approach, finding the minimum, maximum, and we just check. This accurate, ON. The first time, finding the minimum. The second time, finding the maximum. And the third time, we just go to find the number which is not a minimum and maximum. Actually, the third time is O1 because all the numbers are unique. You will find it the third time because all the numbers are unique. What's the ultimate solution?
So 1. So you check the first 3 numbers, but first you have to check if it's at least 3.
Yeah, of course.
Otherwise, -1.
Yes. Yeah, all 3 approaches
So
needs
you
to have
check
this.
the
Yes.
first 3 numbers, you sort it,
Mm-hmm.
and then you pick the number, which is in
the middle, yeah?
Yeah, second.
Okay, well done. Okay, good job. Okay, that's it for today. Bye-bye.
Bye.
Please come. Bye.
Bye.
Bye.